In first part, we discussed 1 to 10 MCQs in 2026 January Unit 1 chemistry paper. So in this section, we are going to discuss question number 11 onward. So let's take question number 11. It asks, what mass of barium chloride is needed to make 500 cubic centimeters of a 0.1 mole per cubic decimeter solution? So they are asking the mass. So we don't have any idea about the mass. So we just said the mass we took is M. So I took M mass of barium chloride. Right. So I'm going to dissolve this barium chloride in 500 cubic centimeters of water because they are saying that volume is 500 cubic centimeter. So the volume here is 500 cubic centimeters. When I dissolve barium chloride in 500 cubic centimeter of solution, they say that I will get a solution with a concentration of 0.1 mole per cubic decimeter barium chloride solution. Right. So there's one part where we have many data. So in the final solution, I know the concentration, I know its volume. Volume is 500 cubic centimeter. If I know the concentration and if I know the volume, concentration we refer it as C, volume is V. So there's the equation. Concentration equals number of moles divided by volume. So using this one, since I have C and V, I can find number of moles. Number of moles equals concentration times volume. Right. Concentration, we know that it's 0.1 moles per cubic decimeter. And since our concentration in moles per cubic decimeter, we have to use volume also in cubic decimeter. So we have to take 500 cubic centimeters. To convert cubic centimeters into cubic decimeter, you have to divide that value by 1000. Divide by 1000 now is cubic decimeters. So per cubic decimeter will cancel out. Your answer will be 0.05 mole. And now I found number of moles of barium chloride I need. But they are not asking the number of moles. They are asking mass of barium chloride. To find mass, there's an equation. Number of moles equals mass divided by molar mass. So therefore, mass equals number of moles times molar mass. Number of moles, we just found it. It's here, so we can put that number of moles, substitute it there. So mass equals number of moles is 0.05 moles times molar mass. Molar mass of barium chloride. Barium chloride has one barium atom and two chlorine atom. Mass of barium atom is given 137.3. So it's 137.3 plus 2 chlorine atoms. 2 chlorine atom means 2 times 35.5. Right. If you do this calculation, then you get your answer as mass equals 10.415 grams. So the closest answer for this one, what we got here is answer C. So question number 11, our answer is C. Let's go for question number 12. Question number 12 says, methane burns completely in oxygen as shown. So they have given us the equation. So we'll write the equation, rewrite the equation again. So we have CH4 gas reacts with 2 oxygen, 2 O2 gas, gives you CO2 gas plus 2 H2O gas. Right. So remember, this is water is a gas here. So that means when you are talking about volumes, you have to consider about water as well. 50 cubic centimeter of methane. Okay. Now we'll go slowly at the beginning. So let's see initial volume. Right. There's another thing. You know that this numbers, now in CH4 there's no number, means it's number 1. In front of oxygen is number 2. In front of carbon, if there's no number, is that number is 1. In front of water, this is 2. So this says that their reacting ratio, we call it molar ratio. So molar ratio in this reaction is 1:2, 2:1, 1:2. Remember, if your reactants are gases, molar ratio works for the volume ratio as well. So therefore, since they have given volumes, I can use volume ratio instead of molar ratio. So I can directly use the volumes. I'll do how it works. It's a 50 cubic centimeter of methane. So at the beginning, we have 50 cubic centimeters of methane mixed with 200 cubic centimeters of oxygen and the ignited mixture. What was the total volume? They're asking the total volume in cubic centimeter of the gas mixture. At the end of the reaction, all gas volumes are measured at the same temperature and pressure. So they are saying that gases. So in the reaction is clearly said that water is a gas, no? So you don't have to worry about like whether it's condensed or not, because they are saying that all are gases. So we consider water is also a gas now. Now we'll assume that when I burn 50 cubic centimeter methane, all of them reacted. So therefore second one I'll write reacted. How much reacted? So let's see. We had 50 cubic centimeters of methane and 200 cubic centimeters of oxygen at the beginning. So I assume this methane completely burns. So out of 50 completely burns. So that means reacted amount is 50. So their ratio is 1:2. CH4 to oxygen ratio is 1:2. So if I add 1 cubic centimeter for methane, to react with it, we need 2 cubic centimeters of oxygen. So to react with 50, we need 2 times 50 cubic centimeters of oxygen. Right. So if I do the math, let's see products and remainings. How much is remaining? 50 were there and 50 cubic centimeter reacted. So remaining, there's nothing here. Here 200 was there. And from 200, 2 times 50, that means 100. From 200, 100 reacts. Okay. So there is 100 remaining there. So we know that their ratio is 1:2:1:2. So if 50 reacts with 100, you get here 50 because 1:2:1. So 52, 2 times 52, 1 times 50 plus 2 times 50 here. So they are asking what is the total volume at the end of the reaction. They can be remainings or products. Both of them are valid. So remainings we have 100. Products we have 50 carbon dioxide and 100 cubic centimeters of water vapor. So when you add them together, 100 plus 100 plus 50 is 250. So our answer for question number 12 is C. Let's go for question number 13. Okay. So there's the equation. They have given the equation PV equals nRT. So we'll also write down that equation. PV equals, P means pressure, V means volume, N means number of moles, R is universal gas constant given, and T is absolute temperature. Right, before dealing with this question, we'll see what are the data they have given. What is the volume? We know what they're asking. They're asking volume. Volume is the question. Of 0.01 moles of oxygen. Our number of moles is given. 0.01 moles. Oxygen at 250 degrees Celsius. But they are giving the temperature in 250 degrees Celsius. But T is absolute temperature. So we have to take the Celsius value 250. For that one, we have to add 273. Then you get the Kelvin value as a temperature. 250 plus 273 is 523 Kelvin. Okay, that's the temperature value. and pressure is given. So we have the pressure is 200,000 Pascal. Yes, we use the pressure in Pascal, so it's fine. Okay, those are the data, and other than that we know what is R. It's given R equals 8.31 joule per mole per Kelvin, right? So now we have all the data in right units because where we can use them. Okay, so I'll just, yeah, so that's fine. Then if you do this all the volumes in right unit, you will get your answer in cubic meters. Remember that, right? Your answer is, it will come in cubic meters. If you put number of moles in moles, temperature in absolute temperature, that means in Kelvin, pressure in Pascal or newtons per square meter, so it's the same, R 8.31. So you get the volume in cubic meters. Let's do the math. So I want us to find the volume. So if PV equals nRT, now we want to find V. V equals nRT divided by pressure. Okay, now let's find V. V equals N is 0.01 number of moles, R is 8.31 universal gas constant, T is absolute temperature 523 divided by pressure is 200,000. If I do this calculation, my volume will come in cubic meters. So my volume is 0.000217306 cubic meters. Do I have any answer with cubic meters? No. Now, but the answers are in cubic centimeters and cubic decimeters. I'll tell you how to convert them. Let's take an example. Now let's assume you have 1 meter. 1 meter means how many centimeters? 100 centimeters. What did you do? To convert meter into centimeters, you multiplied by 10 to the power 2. 100 is 10 to the power 2. But we don't want to convert meter into centimeter. We want to convert cubic meter into cubic centimeter. So we want to convert this one into cubic centimeter. Now how are we going to find the answer? If meter goes to 10 to the power 2 to cubic centimeter, so square meter goes to square centimeter, it should be 10 to the power 4. Because now I'm going to square it. So let's assume I have square meter. I have square meter here. To make it square centimeter, what you have to do is you have to multiply by 10 to the power 2 squared. So 10 to the power 4. Cubic meter into cubic centimeter. Then it will be 10 to the power 2 cube. That means 10 to the power 6. Then you get the answer in cubic centimeter. So if I want to convert this one into cubic centimeters, I have to multiply this thing by 10 to the power 6. When I multiply 10 to the power 6, that means 6 decimal places will come out. 1, 2, 3, 4, 5, 6. So I'll get the answer 217.306 cubic centimeter. Okay, I have the answer. Then you might be thinking how to convert cubic decimeter. I'll teach you that part also. Actually, decimeter means 10 centimeters. So if I want to convert meter into how many 10 centimeters are there, actually 10 of them are there. Decimeter means 1 decimeter is 10 centimeter. So what did I do is I simply multiplied by 10. So if I want to convert square meter into decimeter squared, I have to multiply by 10 times 10. That means by 100. 10 to the power 2. Then you get square decimeter. How I am going to make it? Cubic meter into cubic decimeter. then it will be 10 times 10 times 10. That means 10 to power 3. That means you have to multiply by 1000. Okay, that's 10 to power 3 multiplied by 1000. Okay, that's how you get this volume conversions, right? So here it's 10 to power 3. So answer is 217 cubic centimeters. So our answer is B. Right. Now let's go for question number 14. Now you can see the previous question we discussed, I think, from question number 8, 9, 10, 11, 12, 13. These 6 questions take a little bit time. They are time consuming questions. We discussed in the previous video why they are using these time consuming questions to build up the pressure. By this time you have spent a lot of time. Now your pressure is building up. So when your pressure is building up, you will get panic. When you're in a panic mode, you will make more mistake than you used to. So that's the one thing you have to avoid when you are doing these papers. Question number 14. Which reactions has lowest atomic economy by mass of the formation of calcium chloride? First, we'll see what is the concept of atomic economy, because you know how to do the calculation, but if you try to find the answer by doing calculation and other step, you will consume a lot of time. I'll tell you one thing. The equation for atomic economy, first we'll discuss the equation of atomic economy. Atom economy means atom economy equals desired product. What is the product that you want to have? We call it desired product. Divide by total amount of reactants. Total reactants into 100. The reaction has the lowest atom economy. Now you can see we have the desired product, we have the total number of reactors. Now let's talk about, like, you are in a very, like, now you're in a pressure. You want to finish this question so as soon as possible. So they say that if you want to get a product, to get that product as a percentage, how much amount of atoms you have to spend. For an example, I'll tell you the answer first, then we'll discuss the answer. So when you get desired product without producing any other product, so what will happen? We can say that our atom economy is 100%. Which says that if you use raw materials and if you're trying to produce products, if you are having less waste, then your atom economy is high. That means it says that when you try to make something, you take the raw material. Let's take, you are going to make a wooden tree house. Okay, you are going to make a tree house. To make this tree house, you might be using wood and nails and everything. So you take certain amount of raw materials. These are your raw materials. So when you convert these raw materials into this wooden house, if you don't have any free, like, waste material, if you don't have any waste material, let's assume no waste material at all, we call that your reaction, your process is 100% atom economy is there, because the reason is you don't have any waste product. But if you have waste product, your atom economy decreases. So when I look at this one, here calcium chloride is my desired product. Here I have waste material of 18. Water molecule is, if you do the molar weight, it's 18, because oxygen is 16, hydrogen is 1, there are 2 of them, 16 plus 2 is 18. If you do the same weight and find the molecular weight of carbon dioxide, carbon is 12, oxygen is 16, another oxygen is 16, if you add them together is 44. But you can see here is 18 and here is 2 times 18. 2 18 that means 36. Here there's 2. They're asking one which has lowest atomic means you have many byproducts, many waste products. So when you look at, just by looking at it, you can see here the waste product is very massive, the amount of the waste product. So it's simply 18 plus 44. 18 plus 44 is like 48, 52, 62. So it's 62 grams per mole is your waste product. But here 18, 30 is neither close to this 62. That means there are many byproducts or waste products in this reaction A. So that means I expect that to be the one which has the lowest atomic economy. You can do the math, you will see the result. So we'll do like we'll take A and B and we see by doing the calculations. Okay, because if you do all four, it will be the same. So here you don't need to waste time, but we'll do it. So if I take the atomic economy of answer A, desired product is calcium chloride. Calcium is 40, chlorine is 35.5, two of them is 71, 71 plus 40 is 111. So that's my desired product. Divide by total reactant. Calcium carbon, calcium is 40, carbon is 12, oxygen is 16, and there are 3 of them. So if you do the math, it's 100 plus 2 HCl. 2 HCl means 2 times 36.5 times 100. So when you do this calculation, you will find the atomic economy of first reaction. If you want to find the atomic economy of second reaction, calcium chloride is our desired product, 111. Calcium oxide we have used, which is 56, calcium is 40, oxygen is 16, and 2 HCl. That means 2 times 36.5, because chlorine is 35.5, hydrogen is 1, times 100. So when you do this calculation, you will find the atomic economy. Likewise, you can do all four, then you will find your answer is A. So from that, we know that which one has the lowest atomic economy. It's our answer, because it has more byproducts. But if someone asks which one has the highest atomic economy, then you have to go for one with the least byproducts. So least byproduct is this. So you can say that very low, only 2 hydrogens are the byproduct. All the others are used in the process of forming your product. So this one has the highest atomic economy. More byproducts, less atomic economy. Less byproduct, high atomic economy. That's how you can figure it out. Okay. Question number 15. When one molecule of C10H20 is cracked and reformed, which of these mixtures could not be formed? Okay. Before going for this one, I want to discuss something with you. This is the question. No, we'll discuss that one in question number 17. Okay, let's see this part. Now here, a cracking and reforming. So we have C10H22, right? C10H22. So here what they are going to do is they are going to check the basic concept of chemistry. Other than a nuclear reaction, we know that atoms cannot be created or destroyed. So whatever the number of atoms you had in your reactant side should be there in your product side. So you can see that in reaction A, the product is pent 1-ene. So that means it's an alkene. We know the general formula of alkene is CnH2n. So whatever the number of moles of carbon you have, twice of that will be the number of moles of hydrogen. So we have pent. Pent means 5. Okay, C5. Then you know how many hydrogens are there because this is alkene, H10. Okay, C5H10 plus 2-methyl-but 1-ene. Okay, 2-methyl-butane. 2-methyl-butane. 1, 2, 3, 4. And in the second carbon, there's a methyl group. So it's a alkane. Methyl group is CH3, no? It's a alkane 1, 2, 3, 4, 5. With 5 carbon atom. We know the general formula of alkane, CnH2n plus 2. So 5 times. So if this is 5, so if you want, you can write, you can check the number of hydrogens. You can write CH3, CH, CH2, CH3. Then you can see that it's the same Cn. If it is C5, H2n, 5 times 2 is 10, 10 plus 2 is 12. C5H12. Now you can see 5 carbon, altogether is 10. Done. 10 hydrogen, 12 hydrogen, 22. That means whatever the reactants you had, they appeared on the product side. So that means they're asking could not be formed. So this is a possible reaction. So let's go for the next one. So therefore no need to worry about the first reaction. Second one, Still we are using C10, H22, and we get propene. Propene means alkene with 3 carbons. So it is C3CnH2n C3S6 is the formula. Ethene is an alkene with 2 carbons. So it should be C2. Number of hydrogen will be twice of 2. It will be 4. And 2,2-dimethyl propane. 2,2-dimethyl propane means propane is this. Second carbon, there are 2 methyl groups. So that means again alkane with 5 carbon atoms. Alkane with 5 carbon atoms, we know their formula C5H12. Now let's do it again. 3 plus 2. Carbon is 3 plus 2. 5. 5 plus 5. 10. Done. Hydrogen 6 plus 4 is 10. 10 plus 12 is 22. No issues. A can be a product. Sorry, answer B can be a reaction. Now let's go for question number answer C. Our reactant is C10H22. We are going to crack it. We get butane is an alkane, CnH2n plus 2. But means 4. H2n, 2 times 4 is 8. 8 plus 2 is 10. H10 plus cyclobutane. 1, 2, 3, 4. Cycle means they are like stay as a cycle. So there's something I have to teach about this cycle molecules, but I'll talk to you, like I'll teach you that part in question number 17. So cyclobutane, so we have carbon should have 4 bonds. So this is cyclobutane and ethene. Ethene means 2 carbon with alkene, so it should be C2H4. Number of carbon atoms 10. So here we have 4. 4 plus 2 is 6. 7, 8, 9, 10. Done. Hydrogen is 22. Here we have 10. 4 plus 4, 14. 15, 16, 17, 18, 19, 20, 21, 22. We have 22 hydrogens. So no issues. If A is if A is the right answer, B is the right answer, C is the right answer, you don't have to do the D, because if you are sure about your basics, D is our answer. So let's see whether it's the real one. C10H22, we are just trying to confirm it, but in the real exam, if you are so sure about your A, B, C, the method that you have followed, you don't have to do it again, just mark it as D. So you get pentene, so it will be C5H10 is an alkene, and cyclopentane. So 1, 2, 3, 4, 5. 5 carbon is an alkene. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They have 10 hydrogen. 10 plus 10 hydrogen is 20. But we have 22 hydrogen. Now that's why it cannot be the answer. There has to be a hydrogen molecule to balance the number of atoms, because we cannot create or destroy atoms. So answer is D. Question number 15, answer is D. Now let's go for question number 16. Question number 16, how many sigma bonds and pi bonds are there in a molecule shown? This is the one thing you have to remember. When you see a bond between 2 atoms, it can be any 2 atoms. Remember, always first bond is a sigma bond. If you see a double bond between 2 atoms, let's assume you see not only 1 bond, you see 2 bonds between the atoms. Again, you pick one, that's sigma. Then the other one is pi bond. Then what about if you see a triple bond? Between 2 atoms, you can have 3 bonds. But still, only first bond is sigma. We don't know which one is the first bond. You can pick any bond as well. Just say I'm saying this is first. Or some they like to tell, so middle one is the sigma one. So they like to call it middle one sigma bond. And then other 2 should be pi. So first bond is sigma. Any bonds other than the sigma bonds are pi bonds. So I can clearly see that there's a scenario with 2 double bonds. So one should be definitely pi bond. First one is sigma, other one is pi. So therefore my answer should be where they call there are 2 pi bonds. Okay, I have 2 answers with pi bonds. Let's see how many sigma bonds are there. Now we have to count. Now let's say you are in a real hurry and you want to find the answer for this question with no time. So obviously, don't just blindly, you know that one of these four answers should be the answer, but at least use little bit knowledge that you have. You know, definitely there will be two pi bonds. So answer either, even you go for wild guesses, go for B and C. Don't go for like completely blind, right? So just use little bit, a little thing that you have known. If you know half of the knowledge, that means there's a question need certain amount of theory part. If you know half of it, you don't know completely 100% theory part, but if you know half of it, there's a one point you can eradicate two answers easily from your list. Then at least go for the final two possible answers. So one of them should be the answer. So even if you go for wild guess, go for like intelligent wild guess, right? So you can call it intelligent guess, don't call it wild guess. Okay, let's see how many sigma bonds we have. We have one here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Our answer is C, 12 sigma bonds and 2 pi bonds. That's the answer for question number 16. Let's go for question number 17. Alright, this is the part I said that I want you to teach you something. First, I'll teach you several things. We know that for alkanes, they have general formula CnH2n plus 2. I'll take an example. Okay, this is the alkane. Their formula is CnH2n plus 2. Sorry, CnH2n plus 2. The formula here is, then if it is C3, H2n is 3 times 2 is H6 plus 2 is 6 plus 2 is 8. So it will become C3H8. That's the alkane. So when an alkane convert into alkene, we know that they are going to lose a hydrogen molecule, because these two hydrogen atoms are going to lose. So if I draw the alkene, its formula will be like this. Carbon, so 3 carbon, so these hydrogens are there. As I have drawn in the top two hydrogen atom goes forming a double bond between these two carbon atoms. So that means when an alkane turns into an alkene, they will lose a hydrogen molecule. And their general formula is CnH2n. So the formula here is C3H6, 2 times 3. But if this alkane turn into a cyclic product, cycloalkane, so that means this 3 carbon going to form a cycle. Carbon should have to have 4 bonds, so I should put 2 hydrogens here, 2 more hydrogens here, 2 more hydrogens here. Can you see, still they are C3H6. That means forming a double bond is equal forming a cycle, because when they form a cyclic product also, they have to give away a hydrogen molecule. So I just want to show you that the general formula of both alkene and cycloalkane are the same, CnH2n. So that means forming a double bond is same as forming a cycloalkane in terms of general formula and removal of hydrogens. So remember that part. So keeping that in our mind, let's go again. Let's go for our question. Which two organic compounds are isomers? So I can see in this one there's 1, 2, 3, 4, 5, 6. 6 carbon alkene. Okay. Then do I have anything else with 6 carbon? First you have to find number of atoms should be same, no? 1, 2, 3, 4, 5. 5 carbon. So it can't be isomer. 1 and 2 can't be isomers. 1, 2, 3, 4, 5. 1 and 3 cannot be isomers. 1, 2, 3, 4, 5, 6. 6 carbon here also. 6 carbon, 6 carbon. General formula also same because this is alkene. CN H2N. This is cycloalkane. CN H2N. Yes, they are isomers. So 1 and 4 is isomers. So my answer is B. Now one of you might argue, why only B? Why can't be 2 and 3 can be isomers also? No? This one has 5 carbon. This one also have 5 carbon. But the difference is this is alkane. Third one is alkane. Its general formula is CnH2n plus 2. And the second one is an cycloalkane. Its general formula is same as an alkene. So therefore, they don't have the same number of hydrogen atoms. So therefore, we cannot take, say, 2 and 3 are isomers. Isomers means atoms of the same molecule. Isomers are the molecules of with same molecular formula but different structural or displayed formula. For an example, we'll take this one. Okay, we can take this 1 and 4 again. So isomer means they have the same molecular formula. If I put their carbon atoms, I'll redraw it to give you the right answer, right idea. So we have 6 carbon atoms. So each carbon should have to have 4 bonds. So CH3 here, and there's 2 hydrogen here. This carbon has 3 bonds already. I'll put 1 more. And here they have 2 bonds already. I put 2 more hydrogen. This one has only 1 bond. So I'll put 3 hydrogens. So if I count the number of carbon, it's C6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. H12. Same molecular formula. Molecular formula is C6H12. Let's see for this one. Number 4, 1, 2, 3, 4, 5, 6 carbon are there. So each carbon need 2 more bonds, 2 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C6H12. Molecules with same molecular formula. Molecular formula same, but different displayed of structural formula. Structures are different. Here this is a linear molecule. This is cyclic molecule. So same molecular formula, same different structural formula. We call them. They are isomers. Answer for question number 17 will be 1 and 4. That means our answer is B. Right. Now let's go for question number 18. So in this question, what I want you to teach you that alkene and cycloalkane, they have the same general formula because this is a common thing they check in the exam. So each exam they test that part in different ways. They ask it, how many structural isomers have formula C4H9Br? Now they ask you to draw isomers. Same molecular formula, different structures. Let's see. Okay, first we'll draw the molecule we have, C4Br. Okay, now this is the molecule. So C4H9Br, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is C4H9Br, the linear one. So first thing is, there's one thing called positional isomers. Positional isomers means you just change the place where the functional group is attached. Now my bromine atom is in the first carbon atom. Right. Then I can put the bromine atom in the second carbon atom. I'll just put that bromine atom there. So I'll redraw it. So when I draw it, I'll draw the 4 carbon atoms again. So now bromine atom is not in the first carbon, now it's in the second carbon. Hydrogen, hydrogen. Right. You can do this drawing in your brain, right, when you're doing in the exam. Okay, now this is 1, now this is 2. Now you might be thinking, why can't we put the bromine atom in the third carbon atom? Let's do that way also. Okay, I'll put the bromine atom in the third carbon. 1, 2, 3, 4. Third carbon atom is here now. But the thing is, can you see that if you flip these two molecules, these two are same molecules. How come? You might be thinking, I didn't get it. Think about naming molecules. How to name the molecule? You have to take the longest carbon chain. Yes, we have longest carbon chain, 4 carbon in a row, and number the carbon chain where the attached group get the least number. What is attached group? Bromine get the least number. If I come from this side, 1, 2, 3. Bromine, carbon, attached, carbon atom get number 3. But this is a least number. You can't number the way that you want. You should try to get the least number. If I do it from the numbering from other side, it's again get 2. 2 is less than 3. So therefore, the best way to number this one is this direction. So if I do it, this is 2 bromo. Second carbon, there's a bromine atom. This is also 2 bromo. This is 2 bromobutane. This is also 2 bromobutane. These two are. So this is not a different molecule. It's the same molecule what we have drawn earlier. Now we are done with change the position. Second thing is we have something called chain isomers. Why these 3 carbon has to be in a straight line? Why can't be like this? I can put this CH3 group and put it in this carbon. Let's do it that way. So these are, we call them chain isomers. I didn't change the bromine. Bromine is still there. So I just change this first molecule and I put the CH3 group in the middle carbon. Okay, I get another isomer. And I can do the same thing for this molecule also. While bromine is there, I'll put this CH3 group and put it in this middle carbon. Okay, 1, 2, 3. In the second carbon, we have the bromine here. And I put the CH3 group also here. So now I had positional isomers and the chain isomers. When you do that one, yes, you will come up with all the possible structures. So we have 4 structures here. So our answer is B. Now when you are drawing these structures, if you get confused like this, whether is it a different structure or is it the same structure, best thing what you can do is write their names. Write their names. So if I write this one's name, I should get 4 different names if these 4 are 4 different molecules. So this is 1 bromobutane. This is 2 bromobutane. So this is 1 bromo, 2 methyl propane. 1 bromo, 2 methyl propane. This is 2 bromo, 2 methyl propane. 2 bromo, 2 methyl propane. So they are 4 different molecules because I get 1 bromobutane, 2 bromobutane, 1 bromo, 2 methyl propane, 2 bromo, 2 methyl propane. 4 different names. So therefore those are 4 different molecules. So that means I have 4 isomers. So my answer is B. Now let's go for question number 19. Right. Which alkene exists as EZ isomerism? Let's see what is EZ isomerism. EZ isomerism is simply we can consider as cis-trans isomerism, right? To have EZ or cis-trans isomerism, these are the basic requirement, very basic requirement. First thing is you have to have a carbon-carbon double bond. First factor, check. Alkene, 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 alkene. First factor is fulfilled. Second factor is either side of the carbon-carbon double bond. So let's take right hand side. Okay, this is the right side. In right side, I should have to have 2 different groups. If this is A, other group should be B. Let's do it for this side, left side. Again 2 different groups. If this is A, other group should be B. So they don't worry about this is A and this is also. No. They don't worry about that. They take right side, 2 different groups. Then they take left side, 2 different groups. Remember these 2 factors. To show EZ isomerism or cis-trans isomerism, you have to have a carbon-carbon double bond. If you go a little bit advanced, they are like rotation restriction is not taking place. You don't need to worry about that level. Just remember there has to be a double bond. and either side of the double bond there has to be two different groups. When you go to A2 level, we'll talk about different structures where they don't rotate even though they don't have a double bond, like cisplatin, transplatin. We have molecules like that. For this level, double bond and two different groups. Let's take first example. But1ene 1 2 3 4. But1ene. When never say 1ene, I know that double bond is in the first carbon. If the double bond is in the first carbon, this carbon, the corner carbon, has two hydrogen atoms, similar group. No, it can't be our answer. Second one, 2-methyl-but2ene. Alright, now we have but2ene, O carbon, second carbon, they have double bond. 2-methyl. Here there's a CH3 group. Again, it's rejected because if this is CH3, this is also CH3. Similar group in the molecule, one side of the molecule, so that we don't need to worry about the other side. Third one, but1ene. 1 2 3 4. When they say 1ene, we know that first carbon has a double bond, so obviously one side is hydrogen, is rejected. But2ene. 1 2 3 4, double bond. Obviously we know that if 1 A, B, C cannot be our answer, D should be the answer, but we'll check it. There's a double bond here, so this is CH3 group, this is CH3 group, and the other bond for this carbon is hydrogen, and this is hydrogen. There is a double bond. This side, right side, there are two different groups. On my left hand side, there are two different groups. Yes, it can show EZ or cis trans isomerism. So my answer for question number 19 is D. Let's go for question number 20. What is the IUPAC name of the compound shown? When you are naming a compound, so we can see this is an alkane. So first what you have to do is pick the longest carbon chain. As far as I can see, this is the longest carbon chain. That's the first thing. Right. Then number the longest carbon chain where attached group get the least number. If I number it from this side, 1 2 3, third carbon there's 2 attached group. Just put 3 and 3, 4 5, and the fourth carbon there's another attached group. The second option is I can number it other way around. I'll use blue color for that one. Okay, so I'll use 1 here, 2, yes, second carbon there's attached group, 3 4 5. I get 3, 3. So I can get 3 3 4 and 2 3 3. So 2 3 3 gives me the least number. So therefore I'm not going to go with this numbering method, which is the red color one. Okay. Now I can see what are the groups I can see attached here. So in this is a CH group. So in the second carbon there's a methyl group attached. In the third carbon also there's a methyl group. And we have CH2 CH3 group. So that means it's a ethyl group. In the third carbon there's an ethyl group attached. Okay, so what we have is a pentane. So let's see where there's a pentane. Pentane, yes. Propane, no, never. Butane, never. Pentane. So I have two answers, A and D. So when you select the longest carbon chain, whether you don't know the answer, your answer will be either A or D. Now it is 2-methyl, 3-methyl. There are 2 and 3 methyl groups. So it should be second and third, there should be 2-methyl group. 2,3-dimethyl. But here there's no 2-methyl group, so it's wrong. So 2,3-dimethyl, and there's a third carbon, there's ethyl group. We name them in alphabetical order. Since ethyl, E comes first, so first we tell 3-ethyl, and the 2 and 3, there are 2 methyl groups. 2 and 3 dimethyl pentane. So our answer for this question is D. So we found the answers for first 20 MCQs in 2026 Edexcel IAL examination Unit 1 chemistry paper.